Okay, 10a, we're told that x is greater than y, and x and y are both greater than 0 and whole, so integers, and we're told that 7x minus 5y is 20. Can we find x and y, where x is bigger than y? Right. So if you look at these, this is going to give us multiples of 7, and that's going to give us multiples of 5. And there's going to have to be a gap of 20. Now we know that that is going to be 5s or 0s. So for the gap of 20, what we're going to be looking for is multiples of 7, which end in a 5 or a 0. So let's give it a go. We've got 7x, so this is a 7 times table, ending in 5s or 0s. We've got 35, that's 70, 105, don't know how far this is likely to go up, but there's our number. So of x, in each case that would be 5, 10, 15, 20. So let's plug it in and see what we get. If x is 5, y in each case, if x is 5, that's 35 minus 20. And 3. That seems to work. X is greater than y. Yeah, we're done. That was quicker than I thought. Just to show you, so put in the, so you've got 5y, 5y, let me start again, sorry. So if we know what 7x is, we know it's got to end in 5s and 0s. Those are our possible options of multiples of 7, which can do that. Now we know that 5y is going to be 20 less than 7x. And so we can say that 5y is 15, 50, 85, and 120. Which means that y in this case is that divided by 5. It's 3, 10, 17, and 24. And because x needs to be bigger than y, this is the one that gives us it. X is 5 and y is 3. Okay, made a bit of a meal of that, but hopefully slightly better on part B. Now, you've got a whole load of coins, 30 coins. Jot down some of these facts. 30 coins, a total 170p, and we're only 2p's, 5p's, and 10p's. More 10p than 2p. Okay, now we need to work out how many 5p coins they have to start with. How are we going to do that? Well, let's start off just by making some observations. Again, a bit like the triangle question, kind of playing around, see whether it works. First thing I think we can say is that the number of 5p coins has to be an even number. because we need to have it ending in zeros. Otherwise, if it's not, we're gonna have trouble getting to 170. By the same reasoning, the 2p coins needs to be a multiple of 5 or a multiple of 10. Okay, and this is really just trying to say, well, let's try and get to there. Now we know that there are 30 coins, so the total 10p and 2p. Let's call it a little t and a capital T. So t equals 2p pieces, f equals 5p pieces, and t equals 10p pieces. Okay, we're just going to try and write some equations to link them together. So the first thing we know is that we've got 30 coins, so t plus f plus t is 30. And we all know that that their value is 170. So 2t plus 5f plus 10t, so that's timesing each one by their amount, is 170. And that's giving us some relationships. Okay. What I'm going to do now is I'm going to try and cancel out the 10s, just because it seems easier multiplying this by 10. So we can say 10t plus 10f plus 10t is 300, 2t plus 5f plus 10t is 170. And as with simultaneous equations, if we subtract them, we get 8t plus 5f is 130. So what that's saying is 8 times the number of 2p pieces plus 5 times the number of 5p pieces has to be 130. And you can see straight away with 8 and 5 you've got 10 as a possible option. What I'm going to suggest we do from here is write out a table. Where we start looking at some of the options. Partly, if I'm honest, I'm reverse engineering a bit, where it says show that there's only one solution to the problem. So we can say, well, we've got 2p's, 5p's, and 10p's, and we know that 2's have to be in multiples of 5 and 10. So if you remember that from one of the first things we looked at, 2p pieces need to be in multiples of 5 or 10. So it's one of the things we're going to be using, and let's write it down here. We've got 5, 10, 15. And we also know that 8 times the number of 2p's plus 5 times the number of 5p's is 130. So that's one of our sort of constraints. So if we, when there are 10 2p's, that works. Let's put in values for them. If it's 5 2p's, we have, that's 10p in total. If it's 10 2p's, we have 20p, 30p, Okay, 10 5p's is 50p. If it's 10 and 10, we know that the number of these coins, each row needs to add up to 30. Okay, so adding along there, each row needs to add up to 30. So 10 plus 10, so it means to be 10 10p's, which is 100. So that's £1.70. That works. But look at this. There need to be more 10p's and 5p's. So already that's going wrong. So I'm going to suggest we look here first. So if it's 5 10p's, that means in here we've got 40 plus 5f is 130. 5f is 90. F is 18. So 18. I made a mistake. I didn't. Hold on, bear with me a second. So 40 plus 5f is 130. We subtract that, 95. 5f is 90. No, that's right, f is 18. So number of 5s is 18, which gives us 90p. And so the number of 10s, 5 and 18 is 23. So that's 7 10p's, which gives us 70p. We can check 70 plus 90 plus 10 is £1.70. So the number of 5p's there are, our answer to part 1 is 18. Okay. Now we also, this constraint here, the number of 10p's, to show that there's only one solution to the problem, what we're going to try and do is show that actually as this table carries on, there's going to be more and more 2p's as compared to 10p's. So there's 15 2p's if we carry this on. 8 times 15, that's again 8 times 15 is 820, plus 5f is 130, so it means the number of 5s is 2. 10p. So we've got 15, 2, and it's 17, 13, 130. So already from the table you can see 10p's increasing in 3s, and 2p's are increasing in 5s. Uh, 18 5p's is the only solution. Okay, that I think, if I'm totally honest, is probably my worst explanation yet. I hope it made some sort of sense. If you're desperate for me to redo it, I will have a go. Okay.